Hi, good day. Welcome to the software engineering tutorial, online tutorial. Today in this session, I will be discussing about the class diagram. And I think this will be the last sheet for you, the class diagram. And it takes 2 sessions to complete this sheet. So in this, I hope all of you able to see on your screen class diagram sheet. Okay, if you see this sheet small, so please use the zoom in and zoom out buttons to make appear the screen larger. Okay, so I will be discussing about the class diagram. Okay, in this sheet class diagram, we have total 5 questions. First question is about the class diagram for online shopping, and drawing the class diagram for bank account, and also for health insurance and policy, followed by the class diagram for hospital organization. Okay, these are actually the questions, 4 questions, which I will be discussing in the next class. Okay, today in this class I will be discussing about the basics of class diagram. That is, what is the different symbols of a class diagram. Okay, so first we will take the problem number 5, and in the next class we will solve problem 1, 2, 3, 4 from the knowledge what we have gained from this question number 5. All right. Okay, so let's move to okay, so let's move to the class diagram now. Okay, now the question comes, what do you mean by a class diagram? Okay, class diagram. What is a class diagram? Okay, so class diagram is a diagram, or it's a model, which actually a class diagram models the static structure of a system. Okay, it shows the relationship between classes, objects, attributes, and operations. So you can take down the definition of a class diagram. A class diagram models the static structure of a system. It shows a relationship, shows a relationship between classes, objects, attributes, and operations. This is the definition of a class diagram, which states that a class diagram is nothing but a class diagram that models the static structure of a system. It shows a relationship between, this is very important, a relationship between classes, objects, attributes, and operations. Okay, now in the definition of the class diagram, we have seen 5 keywords. One is called relationships. Okay, now what do you mean by a relationship? Right, and then we have also seen some new keywords called classes, objects, okay, attributes, and operations. So we need to know what do you mean by all of these important keywords. Okay, so relationship I will be discussing in detail at the end. Let me first begin with what do you mean by a class. Okay, so what do you mean by a class? This is very important. Okay, generally class represents an abstraction of entities with common characteristics. For example, you see you are in the section is a class where you have all the students of same characteristics. All are of you having ID card, all of you are having same course enrollment. Okay, all of you have same rules for attendance, right? So this is called a class. A class represents an abstraction of entities with common characteristics. Okay, so it represents it represents an abstraction of entities with common characteristics. Okay, this is the definition of class. Now, here the definition I have given you, but how does it look like? Okay, this is very important. How the class, look like. This is very important to know that. Now, in class diagram, we will draw the class with the help of this square. Yeah. Do you see this? Okay. Yeah. This is a square, and it has many compartments. Okay, many compartments. So many sections. You have one section here. Okay, and then you have another section here. And then you have one more section here. How do you represent in UML diagram a class? I'm showing you that. Okay. Now this is called a class. This is called a class. Now every class has some name. For example, you know that this your Shoba 4500. It's a class. Okay. Now I can give every class has some name. So the name of that class I can represent here. I will write name of the class here. Class name will come here. Okay. Now you know that in the definition of class I have told you that classes has objects, attributes, and operations. Okay. Let us understand what do you mean by first. This attribute. What do you mean by an attribute? Okay. Attribute is nothing but, now I'll give you an example. You take an example of an student. Okay, student is actually an abstraction and an idea, but student means he is not really existing. Who is really existing? Object of the student is really existing. For example, in your Shoba, in your section, you have 15 student. Okay, 15 students. So student is a concept. So what student has? Every student has name. Every student has age. Every student has some marks. Okay, credit hours, all email, phone number. Okay, university ID. All these every student has. So I put that. So I put all of them in all the students I put in a single abstraction called the student. Okay, student as a class. But if I say that Abdullah, okay, he means he is a student, yes, but he's really existing. Abdullah is really existing. So if Abdullah is really existing, then this Abdullah is called an object. Abdullah is called an object now. Okay. But student is a class, but Abdullah is an object of student. Okay. So now in this class, you will have information about the object. For example, if you have a class called student, then you have information about the student, like his name, his roll number, his mobile number, his email, his age, okay, his marks, and number of credit hours remaining. All this information is called as attribute. Okay, so information about the object is nothing but an attribute. So let's write here. You will get attribute here. Attributes. Okay, and what student can do, for example, it can do some operations. Okay, for example, he has to attend the lecture, he has to write the exam. Okay, if he is absent, submit the excuse, do the assignments, all these things. These are nothing but the student has to do the jobs. These are called operations. Okay, we call them as operations. So every class has these things. Okay, every class has this name of a class. Okay, every class they will have the name of a class, okay, and you have an attribute and you have an operation, okay. And optionally some classes will have a responsibility also, okay, that I'm not writing just to show you. Responsibility, but we are not using this in our examples, okay. We are using only these three things, okay: class name, attributes, and operations. Now sometimes there are two ways in which you can represent a class, okay. One way is you can show in a class diagram, I'm talking about, not in reality. In class diagram, either you can show a class with these three things, okay, with these three things: class name, attributes, and operations. These three things are important, okay. And sometimes you will show the class with only two things. What are those? Okay, you will have only the name of the class, okay. You will have only class name, and sometimes you will have only attributes, okay. This is also another style in which you can show the class diagram in you can show the classes in the class diagram. You have only two things, okay. There is one more way, third way. Sometimes for per se you will be using only one section, okay, and that one section has only the class name, that's all. Only you show the class name, that's all. So now I ask you one question: in UML diagram, in how many ways you can show the class? There are three ways, okay. First way is you can show the class in which you can have a class name, you can have attributes, and you can have operations as well. In the second way, you can show the name of the class and also the attributes of the class, okay. And in third way, you can show only the class name, okay. So there are three in which you can show the class diagram. Understood? So I hope all of you have understood this, right? So let's go to the our whiteboard is very big, so we can go on adding the content here. So let's see how long it is, okay. Okay, I have got one question that can't I show the object? Yes, you can show the object. Its notation is like this. When we discuss the class diagram, generally you will have a class and you just give this class names, right? And some here you will write like this: student colon Abdullah, like this, okay. So here this is will be the class name and this is the name of the object, but I will show you while we discuss these things, okay. Now I'm just showing you how to just show the classes in a class diagram, okay. Yeah, objects they are shown only in the sequence diagram and this kind of stuff. In class diagram, as I have told you in the definition itself, what is a class diagram? It will give you static structure of the system, okay. Static. So for capturing the static structure, I need to show only the classes. No need of showing objects also, okay. So there is no question of showing objects here, okay. So good question. Next. Let's see one more thing, that when you give any attributes, okay, or you give any operations like this, attributes or operations, okay. Now this has some visibility, okay. Attributes and operations has some visibility. So I write here attributes and operations has visibility. What do you mean by visibility? Visibility means, for example, let's take an example of student only, okay. In you have a class called student, yeah. So you have a class called student. Now student has some data, okay. What is his data? he has his ID. Okay. So now he has some ID, and he has I think this is very small. I need to redraw a big space, and my whiteboard is limited. I think I have to erase all these things. Is it? Oh, so it is not going. I think it's limited. So I'm erasing all. Okay, is it okay? Because once I rub, I cannot get it back. So I just make sure that you have taken this definitions. Okay, okay, thanks. I've taken these definitions and taken down these important points. Okay, so that I can start from the new board now. Okay, so yeah, I have, for example, I have a class, and I have the name of the class, attributes, and the operations. Okay, and this is student class. Okay. Now this student has some attributes. Okay, what attributes might be? Some attributes like he has an ID, university ID. Okay, so university ID, and he may have his marks. Okay, and he has credit hours. Okay, and some other thing. This is called tilde symbol. Okay, and this is used for package. Now remember, what do you mean by visibility? Visibility means I have a student class. Okay, so when I create an object of this student, okay, when I create an object of this student, so that object, okay, has all these attributes. Okay, he will have an ID, marks, credit hours, and package. Now what do you mean by this plus? Okay, so I should show you in one more diagram that what is it. Yeah, this is called marker. Okay, and here I will be using the visibility, VISIBI. Here I will type visibility, VISIBILI. Okay, now if you have written plus, okay, it means it is public. It is, I will explain what is the meaning of this. And if I have written here as minus, then it means it is private. Okay. Make sure that it's public, this is private, and then you have hash means, yeah, this is hash means it is protected, and the tilde symbol, this is nothing but this, yeah, not another one, not this one. Okay, yeah. This tilde symbol is nothing but this is package level. Now let us understand what is the meaning of this visibility access specifiers. Now, what do you mean by public? Public means you have a student class and there is one more class. Okay, there is some other classes. Now, this class can also see the information. Which information? Only that information which is public. Which is public means outside class can also see the information. Now, you know that as a student, you have no problem in sharing your university ID with anyone. Okay, so that's why I make university ID as public. Okay, did you observe it? Plus means public. So I made university ID is public. But for some reasons, you don't want to give any information about marks to the outside world. Okay, now outside world, if this class want to see the marks, it cannot get access. Why? Because marks are private. Private means it is known, it is only to the object. Okay, public is also known to the object, private is also known to the object. Okay, but the other outside world, they know only public information. Okay, and private information they cannot access. Outside world cannot access the private information. Okay, that is the meaning. Now what do you mean by hash? Hash means it is protected. Protected means protected also. Okay, outside world cannot watch it, it cannot watch it. Okay, only protected are available in the object. Okay, here hash, it is available in the object. Then the question arises, what is the difference between private and protected? Okay, now what is the difference between private and protected? Now private means it is part of the class. For example, marks means the student has marks. Okay, that's why it is called private, and nobody can see this marks, only student can see his marks. Okay, protected means the information which this class will get through inheritance. Okay, so now I'm talking about a relationship. Now there is one concept called inheritance. Okay, what do you mean by inheritance? In inheritance is called is a relationship. Okay, what do you mean by inheritance? Inheritance called is a relationship in which, suppose you have car, you have, for example, a class called, let's take an example of, let's take an example of mobile phone, for example. Okay, you have a mobile phone. This mobile phone, which mobile phone? Your old phone. Okay, so let's take, you have one class called old phone. Yeah, I take this as an, okay, this is old phone, and there is one more class called new phone. Okay, so now you know that in old phone, this is your old phone. Okay, OP I'm writing short. Okay, and here I am writing this is as new phone, NP. NP, new phone. Now in old phone, you can do only two operations. What operations you can do? You can do only operations called make call and receive call. That's all. Okay, you can do only make call and receive call. Okay, so I write here make call one operation. I will write here make call. Okay, this is one operation, and you have another operation called receive call. Okay, in old phone you can do only these things, but now you you have created a new class called new phone. New phone, in this you can send SMS and also you can receive SMS, but new phone should also support making call and receiving call functionality. Okay, so if I write again make call receive call, already you have this functionality in the old class. So again you don't reinvent the wheel again. Why you unnecessarily create new functions which are already there? So now there is a object oriented concept in this context called inheritance. Okay, now this we will use inheritance. Okay, this is inheritance. Now using inheritance, what happens when you mark this as inheritance? Suppose I mark them as protected for them. If I mark them private, private means minus. Okay, private means minus. If I mark them minus, then I will not get the functionality of make call receive call in new phone. No, and the outside world also cannot see this functionality, make call, receive call, because it is private. Okay, what I want is, I don't want outside world to see, but so see, this is called parent, this old class. Okay, I call this as a parent class, and this is called a child class. Okay, now I want this functionality to be available to the child class through inheritance. Then I will mark it as hash. Hash means protected. Okay, when I make this hash, it is same as private, that outside world cannot see it, but this make call, receive call will come through inheritance. So here you can, you just write here, you can send SMS, okay, and receive SMS. Okay, so you have these two functionalities. Now you see, because I mark them as protected here, now this class, child class, will get the functionality of parent class also. It has total now 4 functionalities. What are those 4 functionalities? Make call, receive call, send SMS, and receive SMS also. Okay, so now if you want outside world not to see, but you want to provide only through inheritance, varasa, like it's work like this. Okay, so here this is called as parent class. Okay, this is called parent class, and this is called as child class. Child class. Okay, so it means, see, in the previous definition, I have told you that the class diagram has attributes, operations, okay, and name. All that we have discussed. This is the name, and this is the name of the class. Here you can put attributes. Here you can put operations. Then I discussed about the visibility also of the class, and then here I'm showing you the relationships. Okay, so in association relationships. Okay, associations. So let's talk about now associations. Now associations are of different types. Okay, what do you mean by an association? Association is nothing but how it association represents actually static relationship between the classes. Okay, it, for example, see here is an association between the class called, the name of the association here is inheritance. Okay, so like this you have aggregation, composition, and simple association. So all these are nothing but relation associations. Okay, so let's go to the next topic called associations. So shall I erase this part? I think you have understood this. So here in this, you just understand the meaning of plus, minus, hash, and this. Okay. So plus means it's public. Okay. And the minus means private. Hash means protected. I have explained you these 3. What do you mean by package? Package means, suppose you have a student, then finding student's average, getting his results, marks, all student related files will be kept in one folder. We call them a package. Okay. That is called a package. Okay, so generally a package looks like this. You have a class like this. Okay, then on top of the class you will put here package name, tilde, package symbol. Okay, so I will show you all the symbols, don't worry. So can I go for the next screen now? Do all of you understood, or you have any questions? Yeah, what is the question? Muhammad Umair Muhammad UES. Is that any question? Okay, I think no question. Procedure. Okay, it's clear. Thank you. So let's go for the next screen now. Okay, okay, no problem. Great. Yeah. So now let's talk about associations now. Okay. So association represents the static relationship between the classes. Suppose you have one class here, okay, and you have another class here. Then with the help of association, you will just show that one class is related with another class. This is called association. Okay. This is called association. Okay. Yeah, it's different. But this class will have again these three partitions: name, attributes, all these things. Okay. So I'm just not putting all these things. So what is association? I want to highlight. Okay. Association is you have one class one and you have another class two. Then you will show that how this class one is associated with class two with the help of this line. So we call this as an association. So association represents static relationship between the classes. There is one more thing called multiplicity or cardinality. Okay, so remember, I just write its spelling so that you can understand. Multiplicity, multi, multi, sorry, multi, p l i c i t. Okay, multiplicity is also called as cardinality. Okay, what do you mean by multiplicity or cardinality associations? Okay, now these symbols indicate the number of instances of one class linked to one instance of the other class. For example, you have a class 1 here and you have a class 2 here. Now here I put like this. For example, here I put star or infinity according to the Dr. Abbas. Okay, you can use star or infinity, both are same. Okay, this and here I show this is one here. Okay, so see these symbols star and one, this indicates the number of instances of one class linked to one instance of the other class. For example, you see here we have one, this is for example you call it as an employee class. Okay, so you can have employee one or more than one employees, there are many employees. Okay, but you have all these employees belongs to only one company, so I just write Sharka, right? Company is only one. So you see here company object instance is only one and employee objects may be many. I can show this with the help of this multiplicity or cardinality. Okay, cardinality. There's no H here. Okay, cardinality. Yeah. It's called multiplicity or cardinality things. So here you need to know some important information about this multiplicity and cardinality. I'll just show you in the diagram that there are different indicators here, and you need to know the meaning of each. Okay, so now sometimes you will see here 0 to 1. For example, you see 0 dot dot 1. It means what? It means 0 or 1. 0 or 1 means it is an optional 0 or 1. It can be 0 or it can be 1, but it cannot be 2. It cannot be 3. It should be 0 or 1. That is the meaning. It means 0 or 1. 0 is optional, 1 is optional here. But suppose if I write here 1, in this case what happens, tell me? If I write here 1, then it means only 1. Only 1. It's mandatory. Means let's take in this example, here I have written star. Star means what? 0 or more. Okay, 0 or more. So here you may have no employee, or you may have one employee, two employees, three employees, or you may have infinitely many number of employees. Okay, but when it comes to company should be only one. It cannot be 0 or it cannot be 2. It should be only 1. 1 is mandatory. Okay, that is the meaning of this. And sometimes you will see this also 0 dot dot star. Okay, now in this case, what do you mean by this? This is 0. What do you mean by this? 0 or 1 or 0 or 1 or 2 or 3 or so on up to infinity, so on. Okay, so it means 0 dot star is the, there is another way to write this. You can also write it as simply star, that's all. Okay, or there is one more way to write this as infinity. I'm getting better using mouse, no? Yeah, Abdullah Jibran, is it inheritance, zero or many? The question, I didn't get you. What do you mean by is it inheritance, zero or many? I didn't get your question properly. No, it is not an inheritance, brother. Okay, you are asking that is this is an association. The association is not inheritance, simple association. If it is inheritance, I told you for inheritance you will use the arrow like this. This arrow will be there. But do you see this arrow here? No. So it is a simple association. For inheritance, you will use it like this. Okay. I'll show you in future also. We get some symbols like this diamond also you will get. Okay. When you get this diamond, then it is called aggregation, and sometimes it is filled with, this is called composition like this. Okay. So I will show you all those things. But here this is only a simple association. It is not an inheritance. This is not an inheritance. It is only a simple association. Okay. The association is only simple association. It is not an inheritance. Okay. So now understood zero dot dot star. So here I can write here instead of star, the another notation is I can write infinity here, or I can write zero dot star also. Both are same. Okay. Both are same. Then next, okay. Can you tell me what is the meaning of this? I write here one dot dot star. Okay, what do you mean by this? What do you mean by this? Okay. One or two, oh, very good. One or many. Okay. So it means you cannot have zero here. You cannot have zero is removed from here. You can have one or many. One or many. Good. Okay. So now, is there any difference between these two? Is there any difference between these two? Tell me. Is there any difference between these two? Yes. Here you include 0 and here you exclude 0. Okay. Here 0 is included and here 0 is excluded. Right. This is the difference. So make down the important difference. Okay. Now sometimes you will have only n here. For example, I write just only n. Okay. So in this case, what do you mean by this? This is nothing but only n. It means what? Only n, and this n should be greater than 1. For example, I can write here, for example, let's give me an example of, I have, this is a car, okay, and this car has, this car has wheels, wheels, okay. So I can write one car has 4 wheels, okay, I can write. So when I write 4, it means only 4. It is neither 0 nor 1 nor 2 nor 3 nor 5. 4 means 4 only. Okay. And this number should be not 0. You cannot write it 0 only. You have to write greater than 0. Okay. Not greater than 1. It should be greater than 0. Okay. Please check it. This is greater than 0. Yeah. Okay. And should be greater than 0. And another thing is, sometimes you will have this cardinality 0 dot dot n. Okay, what do you mean by this? If instead of 4, if I would have written, okay, okay, generally you see a car has how many tires? 4 tires. Okay, so 4 is mandatory. So I can write 4 dot dot 6. If I write this, it means a car must have 4 or 5 or 6, not 7 nor 3. That is the meaning. Okay. So it means the range. It can have 4 or 5 or 6, but not less than this, greater than this. Okay. Similarly, you can 0 to n or 1 to n or k to m. Okay, all these are all combinations you can just see. Okay, no need to write here, it is just understood. Okay, now sometimes you will have other types of associations, no, or the relationships. Let us discuss that in the next thing. Is it okay? Shall I go for the next screen? Okay, so let's go for the next screen. You have two relationships here. One is called composition and aggregation. Okay, let us understand what you mean by composition and what you mean by aggregation. Okay, so remember, composition and aggregation. How can I give you an example? Let me think. Hmm. Okay, I think, yeah. See, you have one class, okay, class 1, and you have another class. Sorry. Okay, so yeah, I have a one class C1, and I have another class C2. You know that this is inheritance. Okay, this is inheritance. Okay, now if I have one class C1 and have another class C2, and this is, you see, this is the diamond symbol. Okay, this diamond symbol, if you see, then this is called as an aggregation. It's called an aggregation. So in aggregation, the whole class plays an important role. Okay, but these two classes are not dependent of each other. The C1 is not dependent on C2, and the C2 is not dependent on C1. This is the meaning of aggregation. Aggregation means if C2 is removed, 1 minute, if I remove C2, yeah, if I remove C2, then C1 can exist on its own. But if I remove C1, then C2 can exist on its own. So there is no dependency. There is no dependency between C1 and C2. Then it is called as an aggregation. Okay. Now let us understand what do you mean by composition. Now in composition also, you have one class C1. Okay, and you have another class C2. Okay, and this I have to draw very narrowly. Okay, and I have to fill this. Yeah, so please ignore some small dots, with how much difficulty I'm trying to understanding. All right, so this is called yeah, this is called what is this? Composition. Now, what do you mean by composition? Composition means these two classes, okay, the relationship is the composition means these two classes are dependent of each other. You take an example of, this is a car, okay, this is a car, for example, and this is engine. Now tell me, can car exist without engine? No. Okay, so it means if you remove this engine from the car, then what happens? Car doesn't works. If you have engine, then car works, right? So there is a dependency between these two classes. Then this is called as composition, right? Is called as a composition. And another thing is called generalization is also there. Okay, generalization is nothing but inheritance only, as I have told you in the beginning. Okay, this is inheritance. In generalization, you will have multiple inheritance kind of stuff. For example, you have one class. Okay, you have one class, and you have class 2, and you have class 3, class 4, and so on. Okay, so I can write here like this. This is called generalization. Okay, so just note down, this is called generalization. Generalization and specialization are things of inheritance only. Okay, so we have seen different types of relationships. Generalization we have seen, sorry, generalization we have seen, inheritance we have seen, aggregation, and we have seen the composition also. Okay, so after this, what we'll do is I will show you some important symbols for which are used in UML diagram. Okay, the thing is, let me show you. Copy. So I think, okay, I will take a new screen now. Okay, shall I go for the new screen? Okay, so let's now I'm showing you the different notations of dependency between two classes. Okay, different notations. I'm just showing you different notations. Different notations for different notations for different of dependencies. Dependencies for dependencies, not for dependencies between two classes. Dependencies between two classes. So let me just cut this. We don't have eraser here, good eraser, so I'll just cut this. Now here in this slide, I will show you the different notations for different kind of dependencies between the two classes. Meaning what? Suppose you have one class, okay, and you have another class, okay. If I show you draw like this, what do you mean by this? Okay, these symbols, all associations symbols, I will be showing you in this class now, in this slide now. Okay, now if you have like this arrow, and this arrow is like this, okay, then this is called a simple association. Just now we have seen this called as an association. Okay, and next you have, suppose if the line is direct, yeah, and if this is like this, then tell me what is it? Anyone? We have seen already. What is this? Very good. Inheritance. Inheritance. Okay. And then you have another thing called realization or implementation. For that you will have dotted lines like this. It should be straight. I'm unable to draw all the straight. This is called dependency. This is called dependency. Dependency. and the same dotted line, but the same dotted line, but you will have yeah, generalization and inheritance both are same. Good. Generalization or inheritance are same. So you can also write it as slash or generalization, okay, or slash. You can also use this for specialization, okay. In object-oriented concept, you will understand. I would have teach you with examples how specialization, generalization, and inheritance works in the Java programming and C++. But we don't have it. Please correct the spelling. It's not correct. I don't have. We don't have actually that course here, so I'm just giving you a theoretical understanding about these concepts. Okay. Yeah. Now, if you have this same arrow but like this head, then we call it as what do you call it as? We call it as the realization or implementation. Realization, realization or implementation. Okay. And the last two, but not least, what is this? Oh, I'm sorry. Let's see. This is nothing. Don't see this. Yeah, I will write here like this straight line, and then I draw the diamond like this. Oh, sorry. This is diamond shape. Okay. Yeah. This is aggregation, and if you have same like this, yeah. Now we got it nicely, and you fill it. This is called composition. Okay. Just this, you get the composition. So these are the different symbols, okay, for showing the association between a relationship between the two classes, okay. And one more thing is very important is you see, if I write yeah, just take down this. I will show you in another slide. Is it okay? Okay, so I go for the new one, and here I will write. Suppose you have for class, you will use this, right? You will please see. And for interface, remember there is one more thing called interface. Okay, this is interface. Okay. Interface has only two parts. Okay, name of the interface, and you will have attributes here. That's all. Okay, you will have attributes. Now remember, what is the difference between class and interface? Remember, this is very important. The class can exist in three forms. One form is only the class name. Second form is you can have class name and attributes. Okay, this is the second form. And third form is you can give, okay, you can give class name, attributes, and operations. Okay, but interface exists in only two forms. Either interface will have interface and attributes, or you can have just only name of the interface here. That's all. There are only two notations for interface. Okay. Now, another difference is you can write that you have one class, okay, one class, and you have another class C2. Okay. Then in this case, you write C1 is parent class. Please note down, these are very important points. C1 is parent class, C2 is child class. Sorry, this is inheritance. I have to put this arrow, okay? Child class, and The important thing is you have to write that C2 extends C1. C2 class 2 extends 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 C1. Okay. This is for classes. Now for interfaces, you have suppose one interface. Sorry, you have one interface I1. Okay, and you have another interface I2. Okay. Oh no, please don't see this again. I draw. You have I1 and you have another interface I2. Now, when you write like this, so here interface, here you write interface I2. I write here. How do you read this interface I2? Here is it. Okay. Here you write interface I2 extends interface I1. Okay. Now just remember, how do you read this? Class C2 extends class C1. How do you read it? Class C2 extends class C1. How do you read it? Interface I2 extends I1. But just take down this in next. I will combine interface and class now. Okay. So just take down the important difference. What is the difference between classes and interfaces? Interfaces has no operations. Okay. They don't have operations. They have only name or name and attributes in the UML diagram. And the important difference, third difference, I'm going to show you now here. Suppose you have, can you write here, you have a class 1. You have a class 1 and interface 1. Okay. Can I write it like this? One question. Another is interface I1 and then class C1. Please see this. The first thing is this notation is wrong. You cannot write like this. Okay. You cannot write. No interface can have a parent class. Okay. Always interface has a parent interface only. Okay. You cannot write like this. Okay. This is wrong. Why? Because interface is a child and this is a parent. You cannot have interface whose parent is class. Okay, this is not correct, but this is correct. C1 can have parent, but what line you will put here? You will put this dotted lines. Now you remember where we use this dotted line? Why to use the dotted line? Yeah, this is okay. Now this is allowed. This is correct. Means a class can have a parent interface. Now what is the meaning of this? Interface has operations, but they don't have implementation of an operation. If class is implementing an interface, then it means it is providing the implementation, the body for this operation. So I just write, how do you read this? Okay, class C1 implements interface I1. So you don't write here class C1 extends I1. No, extends comes between class and interface and interface. That's all. Okay. If you have class and you have another class, okay, then only if you write like this, then you have extend. Or if you have interface and another interface, then only you can get extends keyword. Okay. But here I use implements. When you get implement, when you get dotted line where parent is interface and child is class. Okay. So make down this very important. things. Okay, and this is a class, and package is, this is the symbol for package. Okay, this is the symbol for class, and this symbol for package. And for interface also same thing, but you will write like this here. Inside you will have, you will write like this: interface. Interface, this is class, this is package. It's symbols for this. Okay, please take down this. I think with this we have completed the basic symbols. Only one problem of your sheet, that is fifth problem of your sheet, class diagram, the different symbols of class diagram. Okay, so you have any questions? Any questions? No? Okay, so shall we stop? Okay, great, thank you. So so it's a long class about class diagram, so you can have tips, no problem. Right, so in the next lecture I will be solving the problems what is there in our the remaining 4 problems. Okay, with this I will stop here. If you have any questions about quizzes and assignments, let me know. I will answer that query and then I'll stop the lecture. Yes, I think already you have completed how many quizzes? You have any idea? If you want, I can put one activity today or tomorrow or this week. You know that for tutorial you have 20 marks. Okay, welcome. So let me check about the quizzes. How many quizzes we have completed so far? I think there is some problem with the internet. 1 minute, let me check. Okay, I'll just stop my session here and I'll answer your questions in separate video.